Hey guys, I'm going to go over this 3.6 notes in practice. Keep in mind that this will be what your homework looks like. And so if you're having troubles with the homework, hopefully you'll be able to find some help here. We're going to start with question 1. We're going to be finding solutions to polynomials. So specifically, we're going to start with quadratics. So we have these two quadratics. They're trinomials and they're of degree 2. And so typically what we would like to do when we're solving these would be to factor. But when you're looking to factor, one thing that you need to do to check first to see if it's even factorable. So we see that the leading coefficient is 3 and the last coefficient is 1. You multiply those together and you get 3. And then you want to check to see if there are any factors of 3 that will add to be 6. But the only thing that multiplies to be 3 are 3 and 1. So these are the only factors, the factoring pairs of 3, and there's no way that 3 and 1 can add to be 6. So I know that this is not differentiable. And so that means I'm going to have to use the quadratic formula. So we're going to need the quadratic formula. Quadratic formula, x is equal to negative b plus or minus the square root of b squared minus 4 times by a times by c all over 2 times by a. So a is going to be equal to 3, b is going to be equal to 6, and c is going to be equal to 1. So as we put that in, so we're going to say x is equal to negative 6 plus or minus the square root of 36 minus 4 times by a times by c all over 2 times by 3. Okay, and then we're just going to simplify. So we're going to say x is equal to negative 6 plus or minus the square root. Let's see, this is 36. This becomes 12. So 36 minus 12 is going to be 24. All over 6. Now, what you're going to want to do to simplify is to take both of these and divide them separately by 6. So negative 6 divided by 6 plus or minus square root of 24 divided by 6. So we split that up right there, and then we also want to do the square root of 24. And so if you have a calculator, that will simplify for you. That's great. If you want to Google it, in fact, let me see if I can Google it right here. What is the square root of 24 simplified? Let's see. Will it find? I need ChatGPT or something. I need someone that will give it to me straight. Let me go to ChatGPT. What is the square root of 24 simplified? It is 2 square root of 6, and it is correct. Okay, so we're going to say x is equal to negative 1. Okay, that's going to be negative 1 plus or minus 2 root 6 over 6. And then you can simplify this part right here because 2 over 6 simplifies. So that's going to be negative 1 plus or minus root 6 over 3. Okay, so this is probably what you'll use as both of your solutions in ALEKS. Okay, now for the next part, we're going to run into an issue. Well, not an issue. It's just it requires a different way to solve it. But we're going to think about 2 times by 11. 2 times by 11 is 22. And factors of 22 are 1 and 22 and 2 and 11. And I think that's about it. Yeah, and none of these factoring pairs can add to be 5. So this is not a factorable quadratic. So we're going to use the quadratic formula. So we're going to say a is equal to 2, b is equal to 5, c is equal to 11. So for the quadratic formula, we'll say x is equal to negative 5 plus or minus the square root of 25 minus 4 times by a times by c all over 2 times by a. All right, so this is going to be equal to negative 5 plus or minus the square root of 25 minus, I need a calculator. No, not a calculator. So that's gonna be 88, I think. So 88 minus 25. So that's gonna be equal to negative. We'll just say negative 63. Okay, and now we're gonna do. We have to talk about negative square roots of negative numbers. So the imaginary unit. So the square root of -1 is equal to I. And so that's what we need to know to help us solve this right here. And so we can just call this right here equal to -5 plus or minus I square root of 63 divided by 4. So then we can simplify the square root of 63. So I'm going to go into ChatGPT. What about square root of 63? And that simplifies to be 3 root 7. So this is equal to -5 plus or minus 3I root 7 over 4. And there you go. There is the solutions to our quadratic. They need imaginary units. All right, for 3 and for 4, I'm gonna do 4 because I'll give you a lead on 3, but 4 is more difficult, so that's why I'm gonna lead with that one. So we have these factors right here, and we're trying to multiply them in order to get the polynomial. Now, we've never really multiplied factors together that have imaginary units. So what I'm going to do here is first I'm going to, this negative right here that can be distributed to those terms to the right. And so I can write this as x plus 5 minus 6i, and then x plus 5 plus 6i. Okay, and then I'm going to multiply these together. So x times by x is going to be x squared. X times by 5 is going to be positive 5x. X times by 6i is going to be, we can just write that as 6xi. And then 5 times by x is going to be positive 5x. 5 times by 5 is going to be positive 25. Notice how I'm stacking like terms. So I'm going to stack like terms so that's going to be easier to combine like terms. Then 5 times by 6i is going to be positive 30i. Okay, and then negative 6i times x, well, that's going to be negative 6xi. So I'm going to stack that here. And then negative 6i times by 5 is going to be negative 30i. So those stack right there. And then negative 6i times positive 6i is going to be negative 36i squared. So combining like terms, we get x squared, we get plus 10x. Those cancel, so do these right here. We get plus 25 minus 36i squared. Now this I squared, we kind of established earlier that the square root of -1 is equal to I. Say I square both sides, this becomes -1, and this becomes I squared, which helps me right here. Since I squared is equal to -1, I can change that right there. So I can actually change this I squared to just be times by -1. So this right here becomes positive 36. So I get x squared plus 10x plus 25 plus 36. So 25 plus 36 is going to be equal to 61. And there is the final product. Okay, now for 3, just to kind of give you a head start, if you're looking at one like this right here, again, I would just start by distributing this negative right here. So you're going to have x minus 1 minus I, and you're going to have x minus 1 plus I. And there you go, you can multiply those together and get your answer the same way that we did here. I kind of, again, like the technique of stacking like terms. If you do that, you should get something that looks like this. You'll get things that that will cancel, and you'll get an I squared, which will turn to -1. So you multiply that by this number here, and then you can add these terms. It will follow very similar to what you see right here. All right, for 5 and 6. So it's asking you to find a polynomial. We're going to do the same thing pretty much that we did in 3 and 4. We're going to be multiplying factors, but you need to find the factors that you're multiplying. Okay, one thing to keep in mind is that imaginary numbers always come in positive and negative pairs. We call them conjugates. So right here we have 1 plus I and we have 1 minus I. Those are called conjugates. Over here we have -5 plus 6i and -5 minus 6i. Those are called conjugates. They come imaginary solutions rather, come in conjugate pairs. So here is asking us to write a polynomial just like we did in this one right here. But this polynomial needs to have these zeros. So what we're going to do is we're going to take these zeros, turn them into factors, multiply the factors out, and get a polynomial. So that's how we're going to get the polynomial that they're stating here. But in order to have a degree 3 polynomial, we need to have 3 factors. In order to have 3 factors, we need 3 zeros, but they only give us 2 zeros. So what's going to help us here is, again, the fact that we know that imaginary zeros come in conjugate pairs. So that is conjugate. Conjugate numbers. So if you have bi as imaginary zero, then negative bi is its conjugate. Or if you have something like a plus bi as an imaginary zero, then its conjugate is a minus bi. So we know that -4i, which would be the conjugate to 4i, is its so it's the pair. So this tells me that this is how I get my 3 zeros. It tells me I have -2, I have 4i, but I also need to include its conjugate, -4i. So these are the 3 zeros that are going to give me a degree 3 polynomial. Now that I know the zeros, I need to write them as factors. If -2 is my 0, then the factor is x plus 2. If the 0 is 4i, then x minus 4i is the factor. If -4i is the 0, x plus 4i is the factor. And these are the 3 factors I'm going to multiply. Now, keep in mind, just like what we did up here, we multiplied conjugate factors together. Conjugate factors should always be multiplied together when you're looking for the polynomial, because you want these imaginary numbers to kind of go away. And it will be easier if you just start by multiplying the conjugates together. So multiply conjugates together first always. So when I multiply these together, I get x times x, that's going to give me x squared. I multiply x by 4i, that's going to give me positive 4xi. I multiply -4i by x, that's going to give me -4xi. And then minus 16i squared. Again, these cancel out, so we get x squared minus 16, and I squared is equal to -1. So we get x squared plus 16. And don't forget that we need to multiply by x plus 2. But the good part is because we multiplied the conjugates together first, we don't have to deal with imaginary numbers anymore. And so now we just have to multiply these together. So we get x times x squared, which is going to be x to the 3rd. We're going to multiply x by 16. It's going to give me 16x. I'm just going to write that over here because I know that there's going to be an x squared term. 2 times x squared is positive 2x squared. And then 2 times 16, which is going to be positive 32. And there's our polynomial right there. Okay, similarly, we have 3 zeros given to us, but we want to write a degree 4 polynomial. They give us one imaginary zero. So since we know how imaginary zeros work, we can also say that 2 plus I, which is the conjugate to this zero, is also a zero. And now we need to write them as factors. So we have x plus 3, we have x minus 4. As for the other factor, we're going to say we have x minus 2 plus I. We're going to have x minus 2 minus I. So these factors should look similar to what these ones look like. Okay, so the way I look at it is, let's say that you have x is equal to 2 minus I. Well, the reason why you have x is equal to 2 minus I is because you solved for x. So x is equal to 2 minus I. What if I move these terms back over to the x? So if I do that, I would subtract the 2 and add the I. And this would be my factor, which is what I wrote right here. And then if you have x is equal to 2 plus I, again, you would subtract 2, but this time you would subtract the I. So here are the conjugate factors. That's what we're going to multiply together. And so this one's going to take a lot longer because you're going to multiply these together and you're going to multiply those together. And then you're going to multiply those together right there. So because I kind of already showed you how to multiply something like this up here, I think you guys will be good to do that here. And then you'll multiply these together, which we did in the last unit. Then you'll multiply those together. So definitely a difficult problem. Make sure you ask for help in class if you need help on your specific homework question. Okay, because this video is kind of getting long, I'm going to do the last problems in another video.